Alright, time to go through all the problems here from your test review packet. No, there will not be nearly this many questions on your test, so don't worry about that. We want to get right started. The first page, all dealing with similarity shortcuts. In this first problem right here, we have one pair of angles already, and we can say these two are congruent by vertical angles. Therefore, by angle-angle similarity, we can say that triangle ABC, ABC to DEC must be similar to each other. Second one, all we know are two sides. We would need an angle in between them to do side-angle side. We would need an angle here to correspond with it. Or we could have done a third side. If we knew that, we could do side-side-side. So because of that, no, we have no similarity for number 2. And again, real quick, the first one we had angle-angle. So angle-angle worked here. We don't have enough information for number 2. Number 3, we have a shared angle at angle M. Each of these sides here, we have a scale factor of 1 to 2. So we have dm is 1/2 the length of ml, and same over here, mp 1/2 the length of mn. So we have a scale factor, we have a congruent included angle. So by side angle side, we can say triangles are similar, and we have lmn to dmp as a result. Number 4, you need to look and try to figure out what these angles are. If you do the math, you get that this angle here comes as 31 using triangle sum theorem. This angle here is 47. When you do that, you do not have a pair of angles. You have one already, you do not have a second pair. So therefore, we don't have angle-angle, we don't have any sides, so we have no similarity as a result for this problem. Number 5, we have 3 sides that are congruent. We have 2 equilateral triangles. You can say right there, no matter what numbers these are, since whatever you want to call it. If you want to call this 3, then CT and MT also must be 3, and you would have the same with this triangle. Call it 7. You would also have the 7 there and a 7 there. But no matter what numbers you choose, you would always have the same scale factor: 3 to 7, 3 to 7, 3 to 7. Since that scale factor is all the same, you can say by side, side, side that triangles are similar. Honestly, you can have any pair of triangles here because these are all the same side lengths, and actually they are also all the same angles as well. Equilateral is equiangular, therefore they're all 60. So you could have said either by side, 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 or by angle, angle that these two triangles had to be similar. And again, CMT can be similar to any triangle order: SAR, SRA, RAS, any way you want to go. Number 6. You want to look, you have a congruent included angle again. It's the right angle here. Now you need to see if the scale factor matches up. You need to go the shorter of the two sides for both triangles. So from triangle AVQ, you would have the 3. It would have to correspond with the shorter side from the other triangle, which is 6. Now take the longer of the two sides from both triangles, 4 over 8. They both reduce to 1/2. So as a result, we can say that the triangles are similar, FDM and AVQ. Again, make sure you're going FDM, so you're going short side, then the longer side. AVQ, shorter side to longer side. And that is, again, by side angle side. Number 7, all we know is this one angle here. We can say that angle as well has to be a right angle, but we don't know any other sides, we don't know any other angles. We can't figure out anything in this one. We have no similarity. Number 8, you want to look here at, excuse me, at what we have. We have this side has to be 9. This side has the same marking. It's isosceles, so it has to be 9. Same on this triangle. We have a 6. That one has to be 6. So now let's take a look. Match the shorter sides, because we have 3 sides, so we want to think side, side, side. We need to make sure that we have a scale factor. The shorter side of triangle ABC is a 6. The short side of triangle XYZ is a 4. The longer sides, they're both 9 for triangle ABC, and they are both 6 for triangle XYZ. So if all 3 of those are the same, reduced to the same fraction, then they're similar. They both reduce to 3/2, so we do have a excuse me. So now we do have a similar triangle, triangle ABC, similar to triangle XYZ. And then finally, number 9, isosceles triangles again. We don't even need to know what the length of these sides are. We have a congruent angle, that 30-degree angle, and we have these two sides here. We don't need to know what they are, but the scale factor will be the same because you're going to have some number, the 2 hash marks, over 1 hash mark here, and we'll have 2 hash marks over 1 hash mark down there. No matter what, we have the same exact size. Same exact scale factor, so we have similar triangles MNO to PQR. You could have also said, for this one, instead of PQR, you could have said RQP would have also worked. Same with number 8, you could have said XZY as a second answer. So those are similar triangles. Let's move forward. In these, you want to try to draw the picture. So you want to try to draw triangle ABC, and you want to try to draw triangle DEF. Triangle D, E, and F. And you want to try to mark the sides and see exactly how long they are to see if these would be similar. We have 3 side lengths, so you want to think of side, side, side. So take the shortest side from triangle ABC, the shortest side from triangle DEF. That's 8 over 16. The middle lengths are 10 over 20. And the longest length from each triangle is 14 over 26. If you try to simplify each one of those, we get 1/2, and 7 over 13. They're not the same, so the answer is no, they are not similar because we do not have the same scale factor, mainly because of this portion right here. Make sure you check all 3, because if you just checked 8/16 and 10/20, you would get they're both 1/2, and that is not the correct answer. They are not similar because this third proportion does not simplify. In number 11, we're going to have a side angle side here. When you draw out the triangles, you would have A, B, C, and you know angle B, and it would be the same, you know AB, and in side BC. Same with triangle DEF, you know angle E, you know side DE, and you know side EF. So because of that, we're going to be able to use side angle side. Check and see, we want to look at the shorter of the 2 sides for both triangles, so it's 15 and 5, and the longer of 2 sides, 24 to 8. Both will reduce to a factor of 3 to 1, so as a result, yes, these triangles are similar. The similarity statement should be triangle ABC is similar to triangle DEF. And again, following your corresponding parts, AB and DE were the shorter sides, BC and EF were the longer of the 2 sides. So that's how they line up like that. Alright, number 12. Well, 12 through 15 were the ones that we cut out, so we don't need to worry about that. Number 16, this word problem here, we want to try to find the height of the building first. But first it asks us what postulate, what theorem. We can just say, anytime you see that, we're thinking shortcut. So what shortcut are we using here? The shortcut we want to say is, well, first look, do we know 3 side lengths for both triangles? Absolutely not. The big triangle is the building and its shadow, the small triangle, the person and his shadow. We don't know side lengths, all 3 of them, so we can't say SAS. We don't even have 2 side lengths, so we can't say SAS or SSS now at this point. That leaves, the only thing we should be looking for now is angle. The first angle was given to us, the right angle. The second angle is this right here, a shared angle between the 2 triangles. So now we need to approximate the height of the building. To approximate it, we want to say, if we take the height of the building, which we don't know, it should correspond to the height of the person, which is 72 inches, or 6 feet. So we're going to say 6 feet as a result here. We want to set that equal to, we need to correspond. So we went building to person. Now we want to go the building shadow, which is 24 feet long. Make sure you recognize the triangle goes all the way out to the end here, 20 plus 4. And that needs to correspond to the shadow made by the person, which is 4. You do your cross multiplying, you get 4x equals 24 times 6. And then when you do your division, you come up with an answer at the end of 36 feet. Now, for the part C here, we're now having another person that we're in the equation. So it's like we have, another person. This is a very, very poor drawing, of course. But it's like we have this person who is 62 inches tall, and we want to know how long this partner's shadow is. So you can do it either from the building's height, which we now know is 36. You can do it from the person's height, which we knew was 72. So say original person 72 inches to the height of the partner 62 inches. It should follow the exact same pattern. The shadow of the original person was 4 feet. The shadow of this new person, we don't know. Call it y. So when you cross multiply, 72y would equal 4 times 62. And then when you get your answer in the end, dividing by 72, you should get that the length here is going to be, if you did it like this, it is in inches, it is 41 1/3 inches. If you did it in feet, if you converted 72 back to 6 feet, and you made this 6 2/12 feet, or I'm sorry, 5 2/12 feet, then you would have gotten an answer in feet, and that answer would have been 3 4/9 So either way, either one is an acceptable answer. This would also be 3 feet and 3 feet, and how many inches would that be? 5 inches? 3 feet 5 inches? Yes. So that's the way you want to look at that. Either one of these would be valid answers, either as fraction form. If you want to try to convert it, I would leave it as a mixed number or as an improper fraction. That is going to be just fine. Alright, finding the value of the variable. This is dealing with finding the proportionalities. So number 17, you want to look at a over 3 would have to equal, so we went left to right, we need to do the same thing, the left to right, 6 over 4. For example, for this one, you could have also done a over 6 would have to equal 3 over 4. Do your cross multiplying. Either way, you would have 4a equals 18, and you would get that a has to equal 18 over 4, which reduces to 9 over 2, or 4.5 if you prefer to decimal. Number 18, we want to say, again, if you go left to right, x over 10 would equal 6 over 8. You can reduce this first if you want, or you could cross multiply immediately. I like reducing first, but it's completely up to you. And you would get 4x equals 30, and you would get as an answer x equals 15 halves. X equals 15 over 2. Number 19, same thing. I'm going to go top to bottom this time. 12 over 8 equals 9 over x. Again, if you want to try to reduce ahead of time, you can, or you can cross multiply immediately. If you do it immediately this time, 72 equals 12x, which leads as a result that x has to equal 6. In number 20, we want to say, either way, let's go left to right. Let's go 3 over 6 has to equal 5 over x. If you did top to bottom, 3 over 5 equals 6 over x, as long as the corresponding pieces match up. So here you'd have 3x equals 30, which leaves x equals 10. And that would work for going the other way as well. Number 21, what you want to look at here again, in this case, we need to first say that lines are parallel. In number 18, we could do it because they're parallel immediately. In 17, 19, and 20, we could do this because we knew that the angles had been bisected. We were given that. We don't know these lines are parallel yet. Well, we actually can figure that out. 60 and 120 are supplementary. They add up to 180. These are consecutive interior angles, and they add up to 180 degrees. Therefore, one of our theorems, the consecutive interior angles theorem, said those lines are parallel. Now, because of that, we can set up the proportions. If we go 4 over 12, would have to equal x over 10. I'm going to reduce first, just to be different this time. And as a result, we will get that 10 equals 3x, which means that x would equal 10 over 3. Number 22 now. Number 22, we need to find some more information. All we know are these few angles. We don't know, again, if we have these angles bisected yet. We need to check that first. This angle here, its supplement for this linear pair would be 94 degrees. Then if you do triangle sum theorem with 81 and 94, that leaves 25 degrees for this angle. So as a result, yes, this angle is bisected, so we can now go 3 over 7 equals 4 over x, cross multiply, and we would end up getting an answer of x equals 28 over 3. And last but not least, number 23. This one is pretty easy to set up. If we go 6 over x, it would have to equal 4 over 4, and you can see that immediately, x equals 6. You can try to do the cross multiplying if you want. You would get 24 equals 4x. Alright, keep on rolling. We're almost there. On to the back page. Those were ones we didn't need. We looked at them already. We're in good shape. Number 24. We want to figure out how to do these proportions. GC to CF. GC to CF, those are little piece to little piece. So we want to see another pair of little piece to little piece. Something to DB. The little piece that's left is GD. So GD is your answer there. 25 here is something a little bit different though. And number 25, we have to look beyond little piece to little piece. In this one, we're going CD, which is not a little piece anymore. Now it's a parallel line, to FB, another parallel line. So instead of little piece to little piece, we need to look small triangle in pink to this big triangle in blue. Pink triangle to blue triangle, CD to FB. GD is this segment up here, this small segment from the first triangle. So GD is on the right side of the triangle, we need to have the corresponding piece from the right side of the triangle. From the bigger triangle this time, which is GB. So that's how we get that answer. For the third one, again, we have FG this time. So we're having a big piece, FG, and in this case, AG. So little piece to a big piece is going to equal FB, which is this small part, or I'm sorry, this parallel line. So see, we have first this triangle made of red and green. We need to take the corresponding part from this blue triangle, the big triangle, which means this has to be AE as a result. 27. AF over FC. These are two small pieces, AF to FC. We also have something then to BD. The piece that was left here is BE. 24 and 27, most of you are pretty good on. It's getting these other ones to work that are a little bit more tricky. We have, in the next one, we have AE to CD. And that needs, again, to correspond now. AE to CD is to GE to something. Well, this is the right side of this big triangle. We need to now find the right side of the smaller triangle that corresponded with CD. And that's the only thing that's left here is GD. So the answer here is GD. And last, and certainly not least, number 29, we have, excuse me, we have for number 29, GD to GE. So we have short piece to long piece is something to AE. So this should be very similar to what we just did. The longer piece goes with that triangle. We need to get to match with AE. We need a parallel line to it. The parallel line it corresponds with this small piece GD is this parallel portion CD. So your answer for 29 is CD. Number 30 and 31. We need to find a scale factor. We're using side-side-side similarity here. To find the scale factor, again, match the smaller sides from both. So that's 9 and 6. The middle sides from both, 12 and 8. And the top and the bigger sides, 10 and 15. They should all reduce to the same thing. Oh, I switched that up, I'm sorry. This should be 15 over 10. Make sure you go with the same triangle. So ABC to DEF, ABC to DEF, ABC to DEF. They should all reduce to a factor of 3 over 2. That is your scale factor going from ABC to DEF. We want to look at the same thing here. The short sides is 18 to 24. Middle sides are 21 to 28. And the long sides are 33 to 44. So what we're going to do here, when we reduce them all, we should get a fraction of 3 over 4. That is your scale factor. Number 32, you need to try to pair each of these up. Again, short side to short side, middle to middle, and long to long. When you did that with ABC and DEF, you got fractions that weren't equivalent. For example, you should have had 5 over 4 would have to equal 6. 5 over 4 would have to equal 7 over 6. It does not happen, so that doesn't work. If you tried to do, sorry, that was for ABC and DEF. If you tried to do ABC and GHI, you would have gotten 5 over 2, small to small, would have to equal 7 over 3, which they do not. This is 2 1/3, this is 2 1/2, so that's not going to work. So the only possibility left is DEF to GHJ. You would have to do 4 to 2, which will reduce to 2 to 1, 6 to 3, which also reduces to 2 to 1, that's good, and what's left is 7 to 3.5, also reduces to 2 to 1. So the scale factor here is 2 to 1, or 2 over 1, and you would say that triangle DEF is similar to triangle GHJ. Last set here, 33 to 34. 33 and 34 here, these are similar, we said, by the proportionality converse. They are similar if these sides were split up proportionally. So if you said that 7 over 8 would then have to equal 2 over 3. Do they equal 2, or do those fractions equal each other? If you cross multiply, you would get 16 and 21. Well, they do not equal each other. So that tells us right away, no, they are not equivalent fractions. You could also try to reduce both of these and see if they were the right answer. You could try punching them into your calculator, and you would get 0.875 for 7/8, and you would get 0.6 repeating for 2/3. Not the same number, not the same fraction, therefore not a valid answer to say that these are parallel. 34, same idea. If let's go 6 over 9 for them being proportional this time. 6 over 9 would have to equal 4 over 6. You could have said 6 over 4 and 9 over 6. That would have worked too, either way. So when we do these, if you cross multiply, you would get 36 and 36. They equal each other, so yes, they are parallel. You could have also, again, tried to reduce these. You would have reduced to a fraction, both of them, of 2 over 3. Alright, determining the length of each segment down here. AG is this segment right here. It is a little piece, so we want to be thinking little piece to little piece. We want to look at what values we know. If we set up a proportion here, if we go this piece, we'll call it x here. If we go x to 4, it would have to equal, x to 4 would have to equal 4 to 6. When you do the cross multiplying, you would get that 6x would equal 24, which means that you would get an answer here. Did I do that right? I'm sorry. 6x would equal 16. My fault. 6x equals 16. You do the division. X would equal 8 over 3 as your answer. Second problem, FC. Again, like we did before in 24 through 29, FC is one of the parallel line portions. So what we want to do here is now say, okay, we're going to want to look, because this is a parallel line, it is not a short piece, we want to look for similar triangles. So we want to look at this big green triangle versus this triangle that I'm now highlighting in pink. What we want to say, that if we do FC is the parallel line, it would correspond to the smaller triangle in pink of, which is a length of 3, GB. And what do we know? We know the length of this big triangle here. It's 10. And we also know that corresponding little triangle of AB has a length of 4. Do the cross multiplying, and you would get that 30 would equal 4 times this value, if you want to call it y, just so we can be consistent. That 30 would equal 4y, and we would get as an answer that 15 halves equals y, or equals this length for FC. For ED, let's call this value, I don't know, let's call it value j. We haven't used j yet. To find ED, we're going to do the same exact thing. We're going to use big portion, this big triangle in blue, versus the little triangle there in pink. So j over the corresponding piece, this parallel part 3, is going to have to equal, the length of this side is 15, and the length of the small side that corresponds is 4. So you would get, when you cross multiply, 4j equals 45, 45, so we get that j equals 45 over 4. Now, for this last problem, I'm going to erase real quickly so we can be sure we can see it. For this last problem, we want to look at segment AE, which is this big long segment right here. We can try to do it piece by piece. That would be fine. The way I would try to do it, if you set up this big long triangle versus, I'm going to do it versus this small triangle here, AGB. We know AG already. We know some other side lengths already. But this is what how I'm going to set it up. If we call this big segment AE, let's call it Z. This big long segment we're going to call Z. So Z, the big segment, has to correspond to this smaller segment, G, which is here is GA. We said that was 8 over 3. Just remember it as 8/3. If you want it in the decimal, 2 and 2/3, 2.6 repeating. It would have to equal, we're going to go now with this long side over here. This long side is 15. The corresponding side here is 4. When you do the cross multiplying, 4z would equal 15 times 8 over 3. Well, 15 times 8 over 3 is going to be 40. When you do it, you want to type in 15 times 8 divided by 3, you would get 40. When you do the division at the end, z equals 10 is your answer. This is one of the trickiest problems that you had on this entire review sheet. If you can do especially just this one, these last 4, and problems 24 through 29, you should be in great shape for doing the proportionality ideas on this quiz. Well, that is it. I hope you have found all your answers. Make sure to get all of the proper work copied down for these, and good luck on your quiz tomorrow. Remember, it is a short quiz due to shortened periods. So, hope all is good, and have a good night.